Hello everyone, welcome back to my channel. I am Kedar, and in this video we'll be looking at morphing the 2D patterns that we created in the previous two videos onto 3D surfaces. And like I said in my earlier video, I did not plan this to be into two parts, but because the earlier video became big, so I was like, okay, let me split it into two parts. So in this video we'll be focusing only on morphing patterns on surfaces and looking at some of the key concepts like what are control points, what are NURBS surfaces. My Lisp can't get NURBS and surface in one sentence. And lastly, we look at what are isocurves on a particular surface. So let's just get right into it. And now let's look at how to create or transform whatever patterns we made onto a surface. Okay. So basically what we will look at, we created these patterns. Now we will look at how to create these surfaces and transform or morph these patterns onto this surface, which if you can imagine is much more easier to do this way rather than directly getting a surface, then mapping things on top and then using an attractor. To do this, we only need to use one particular component inside of Grasshopper, which is called as surface morph. And it does what it says. It will morph your pattern onto a surface, okay? And it has 6 particular inputs. The first input is geometry, which is what is the geometry that you want to morph, which is in this case the 2D patterns that you have created. Then reference, let's see, then is your surface. So it's asking you what is the surface that you want to morph this particular pattern on. So this is my surface. Then below the surface you will see U, V and W domain. Now what does this mean? So let's take any particular surface and it has X dimension and Y dimension, or it's called U domain and a V domain. So basically you need to give surface morph what is the dimensions of these particular surfaces, and this we can extract using a component called deconstruct domain square. So basically what this component does, whatever you give it a surface, it will give you its dimension on X and Y or U and V, and then W is your thickness. So what is the thickness of the pattern that you want once it is morphed? So now we have added the surface and its dimensions. The same we need to do for the 2D pattern, but below geometry it doesn't say U, V and W, it only says reference. So what we do, rather than giving the entire or rather than giving the X and Y dimension, we encapsulate this particular pattern into a box using a component called bounding box, and then connect the bounding box to reference. Okay, time for some Grasshopper knowledge or some trick. So sometimes what happens is that in a Grasshopper component, you might not exactly have what you want. So you need to figure out a way to use it. For example, let's say you don't have an U and V value, but they have something called as reference. So I can put this into a box and then give this as a reference. Okay, and when we connect all of this, this is what the script look like. Very simple. So your 2D pattern goes to the geometry, which goes to bounding box, and that becomes your geometry and reference. And the pattern or the surface that you want to morph the pattern on, that becomes your input surface. Then we use deconstruct domain square. We get our U and V value, and W is the thickness of how much over thickness you want the pattern to be. And then we get the output. Simple, super simple. But before creating this, I wanted to introduce you all for some key concepts in Rhino, because we will be modeling these patterns inside of Rhino. So basically inside of Rhino, whatever you manipulate, we use these called as control points, because to manipulate any particular single surface, you can't directly touch the surface. These points help you to move the surface. It is similar to control point curve where you add degree. So degree 1 becomes very sharp, degree 2 smooth, 3 more smoother, and 5 even more smoother. And the way we transform any surface inside of Rhino is by manipulating these points. Okay, and this is because Rhino works with something called as a NURBS geometry or non-uniform rational B-spline. Okay, this is a huge word and I will try to break it down to make you understand as simple as possible. Okay, so let's break this down into 3 parts. First we'll look at what is non-uniform, then rational, and then B-spline. So basically non-uniform means that the curve has the ability to bend unevenly throughout. For example, if you see here in this case, we can get sharp edges, we can also get smooth edges. Okay, and because we have non-uniform or unevenly distributed curve, we get more precision over the surface or a particular curve. So that's basically what non-uniform means. Then rational means that each control point we can define a weight to it. So let's say I say that this particular point has to be 1 meter above, this has to be 3 meter above. So I can give more or less weight to it depending upon how I like it. Is this not in one line? Damn, okay, sorry, bye. I don't know. My OCD never stops. Okay. And then as a result of moving these points, whatever output you get this smooth curve or smooth surface. That is what we call as a B-spline. Okay. So basically whatever NURBS gives us, in short, they give us smooth and flexible geometry for us to transform. So I try to compare this with other type of modeling, which is polygonal modeling. So NURBS modeling, we have tools like Rhino, CATIA and others. Polygonal modeling, we have tools like SketchUp, Blender, and there are others as well. And right off the bat, you will see that the output of Rhino is smooth, whereas the output from SketchUp is this segmented or faceted kind of polygons. But you have to understand that it's not like one is better over the other. There might be instances where you want to use a polygonal modeling. For example, with Blender, or whenever you're doing a character modeling, there are so many undulations on our face. It's very difficult to work with NURBS because it will not create a very good shape of the face only with one singular NURBS surface. Of course, you can make it a patch of different NURBS surfaces, but creating one surface doesn't work. Or for example, even if you take fingers, right, you have to split this. So this will become one NURBS, this will become another NURBS because it has to bend somewhere. But when you have polygonal modeling, the same can be gone throughout. I sometimes give this example like NURBS is kind of illustrator. No matter how much you zoom in, you will end up with a smooth surface. Whereas polygonal modeling is like Photoshop, where you zoom in, you see these pixels. And again, I want to emphasize that it's not like one is good than the other. For our case, which we are using to create 2D patterns, it's much more important that we can morph the pattern directly onto a surface and it is not broken into smaller surfaces. Okay, and the last concept that I wanted to talk about is something called as a isocurve. Okay, there are too many things, but this is a little bit important because it will affect the pattern that we create and morph it. Okay, so basically whenever you create any surface inside of Rhino, you get these lines on it, which basically depict what is the direction of this particular surface. Okay, versus there is something called a seam where you combine surfaces. So you see these thick white lines. These are when different surfaces come together. We don't want to work with various surfaces. What we want to work with? We want to work with single surfaces for this particular case. Because you can't directly push all of these patterns onto multiple surfaces, and if they are not really designed together, they will not look nice. So let's stick to one particular surface. And now we know that we will manipulate the surface using control points. So let's say while moving the control point, the shape of this U and V direction becomes something like this versus something like, which is very orthogonal. This becomes like this S shaped. Now this will affect the way the pattern gets morphed on this. So if I push the pattern on the surface, you will see on the left hand side, the pattern kind of takes the shape of the surface or the isocurve, and the right hand side, the pattern is taking very orthogonal view from the surface. Okay. So if you look at it more detailed, so you see this particular piece is skewed and this particular piece remains rectangle. If you look this from the top view, you will see how the pattern is kind of morphing to the shape of this surface versus the same surface. The only thing is I have moved the isocurve. So whenever we transform, you can also move the shape of the isocurve by just moving the control points and you get a totally new surface. Okay. So now let's see how to transform our 2D patterns onto the surface using surface morph. So firstly, let's create a surface in Rhino. So I'll double click on perspective inside of Rhino. Okay. This is not, I didn't find this rule anywhere, but let's say we have this pattern and I want to morph it onto a surface. So what I do generally, whatever is the ratio, let's say I have a landscape pattern, I create a landscape surface. Let's say I have a square pattern, I create a square surface. Simple. So in Rhino, what you got to do, you see this on the left hand side, you see this icon which says surface from 3 or 4 point corner. Right click on it and then you get different options. Here you can just say surface or rectangle plane corner to corner. I'm going to create a plane something like this. If you want, you can add dimension as well. So let's say I had 1000, enter, by 1200 or 1300. Okay, so this surface is 1000 by 1300. It's up to you. If you feel like you want to do it visually, that's fine. Or if you feel like you want to give a specific dimension, that's also fine. So now let's see how to morph this. And you will not see the surface like this. There will be the isocurve. I have offed it. So if I click on it and if I click here, then I see surface isocurve. If you off it, you will not see the grid. If I on it, I will see the grid, but I have kept it in a way that when I only click on the surface, I see the isocurve. If I don't click on it, I don't see the isocurve. It's fine, it's just the display settings. Okay, then to see the control points on any surface, you can either select the surface and type points on, and you will see now it has only 4 corner points, or the other option is select the surface and type F10 on your keyboard, so you see the corner points. Okay, and now if I move the corner points up, so if I select this, I hold shift to select multiple, and let's say the height is around 500, you see you get this kind of a surface. Amazing, nice, super cool. Okay, then we can also rebuild it, but right now let's just check if the pattern goes on this or not. Okay, so we need to take a component called surface morph. So we go to transform, morph, then we say surface morph. Where are you, sir? This one. And like I said, it has 6 inputs. One is what is the geometry that you want and what is the surface. So first let me take the surface inside of Grasshopper. So we go to params, geometry, I take surface, where are you? Right click, set one surface. So the surface is here. So the surface goes to surface, and then U and V is the dimension of this particular surface. So we need to go to math, domain, and we say deconstruct domain square. Not this one, the below one, deconstruct domain square. There are 2, one which gives you minimum maximum for 4. We don't need that, we need the below one. So then I connect the surface here, and now you will see the dimension. So if I click my mouse over U, it says 0 to 1000. So if you remember, I had added the dimension as 1000, and V is 0 to 1300, which is what the other dimension was. So this goes to this goes to U, this goes to V, and then thickness of whatever the pattern is. So let's say I keep the thickness as 10. Now we need to add the geometry and the reference. So if I directly add this, you see what happens. Now firstly, because they are all separate, I will again group them together. So I'll flatten the data. So I go to set tree, I will flatten all of these so that they can come in one particular set. Let me move this little bit this side. Now we need to add the reference and the geometry. Okay, so let's say I add the tree to the geometry. And the reference, like I said in my presentation, we need to again give it what is its size. Okay, so I use a component called bounding box. So I go to surface, primitive, I say bounding box. I connect the flattened tree to content. It has output of 2 boxes. I have never found any differences, but I always use the first one. And if I connect it here, error. If I click on it, it says the reference space volume can't be 0. Okay. So this is something that we got to do because the pattern is flat, has no thickness to it. So we need to give it a thickness little bit. So basically we need to extrude it a little bit, otherwise this error will be there. So what we do, we go to surface, freeform, we say extrude surface, okay, which basically is giving it a thickness. Now the direction is whether you want to extrude in X, Y or Z. I will extrude in Z. So I go to vector, unit of Z. Okay, and then I connect the tree to the base. The the Z vector goes to direction, and it says unit vector because you will see the factor is 1, and unit is always equal to 1. Okay, and now I connect the extrusion to the bounding box, and I will connect this extrusion to geometry, and it takes time, and we need to make this union box and not per object box. And now let's see what happens. Where are you? Can you show me the pattern, please? Yes. Amazing. So what all did we do? So we added the surface from Rhino. We deconstructed it so we get its dimension. We gave it a thickness of 10. Then we flattened the tree so all of those patterns could come inside one data set. Then we used bounding box, but when we directly connected, it said you can't do it because the pattern is flat and has no thickness. So then we extruded it a little bit, and then I added a bounding box. But the bounding box, if you right click, has 2 options. Either you can do it for individual pieces or for the entire set. And if I do it for the per object, it means that there are 1160 boxes and you don't get the correct output. So what I did, I right click and I say union box. So we get only one single box for the entire pattern. So you will see here we get one box and then the pattern flows. And how amazing is this? Let me take this, let's connect it here, or let's go to rendered, and you will see whatever the pattern was there below has now come on this particular surface. How cool and how simple. Just by using surface morph, you can transform your pattern or morph it onto any particular surface. Okay, now let's change the surface a bit further and see what can be done. Okay, so whenever you are changing the surface and whenever using surface morph, please don't change it when it is connected, because you see each iteration you do takes 1 second. So always what I like to do, I like to disconnect it. So if I go to Rhino again, let me go to the shader view, and let's say now I want to make it something little bit smooth. So what I will do, I will say rebuild. Okay, so right now you saw that you had only corner points. So you had a point here, here, here and here. But if you want to make the surface more smooth, you will need points on the surface as well. To do that, we need to rebuild this surface. So you type rebuild, R-E-B-U-I-L-D, and these are the functions, or these are the parameters it asks. So it's asking me how many points you want in U and V. Let's say 5 and 5 is fine. And then what is the degree? So this is the degree of smoothness. So I've kept it 3 and 3. And do you want to delete the input? I say yes, please delete the input. And then the same surface, now if I on control points, you will see has more points on it and I can move it. So let's say I select these 4 points. I select these 4 points holding shift, and this I make it something like that. Okay, so this is up to you. Whatever you want, you can do it. I'm just showing how control points work. Of course, you can add distance as well. And I can say move these 4 points a little bit down. I think something like this looks super nice. Okay, then I right click, I say set one surface. I select this surface and then I connect it here. Now it takes a couple of seconds, and now to this new surface, our pattern gets morphed. And how amazing! I have no idea about you guys, but I love this. I love the way Grasshopper is so iterative, and you do little bit of understanding if you have of where things get connected. You can do amazing things with this. Okay, so now once this is done, all you gotta do, create new surfaces, change the pattern, and boom, it's done. Okay, now let's say something simple we do. I'm gonna make shaded. Now let's say I want to create something like a flower pot or a vase or something. Okay, so what I will do, I will type circle. Let's say this much diameter is fine, and then I will say extrude. So I'll select this and I type extrude curve, C-U-R-V. Where are you, sir? Extrude curve here, and then I give it some kind of a height. So now this is a cylinder, okay, which has a height. Now we can always on control points, or we can rebuild this. So I say again rebuild this, and now I think the same points I can keep it. One thing to remember, don't keep more points, because let's say, okay, let me do it. Let's say I keep 25 by 25 and I say okay, and then I will say points on. Now what happens is that, let's say I only select these and move it. It becomes more of a local transformation, like none of the influence of these control points have on this. But rather, if I create less control points, for example 5 by 5, even if I make changes here, it will affect the entire geometry. Okay, so if you want more of a local zoomed in kind of change, then add more control points. But if you want more of a global geometric change, then add less control points. Okay, I'm going to control Z and then rebuild this, and same, let's say 5 by 5 should be fine, and then we on control points. Okay, and now I can deform this, so I can hold shift. Let me go to front view. Let me go to shaded here. I can deform this the way I want it. It's up to you. And let's say we do something like this. Looks nice, simple, nothing too complicated. Yeah, I like it. Although I wish it was inverted. So I'm gonna invert this. Yes, much better. Nice. Okay. Then what we can do, you can use the same script. So I will change the surface, or what I will do, I will group this here so that this pattern exists, and then I can copy this script again. And now let's move this to this pattern that I created. Then I'm going to connect this ruled surface to graph tree, and then the same extrusion doesn't really matter. And now I will use this, whatever this transformed cylinder is. So I say set one surface, connect it. Now let's see what we get. And on this cylinder, you see it has morphed that particular pattern. You see how nice. Okay, of course we got to adjust things from this particular pattern, but whatever the pattern was there, we can see that. So this was the pattern that we had. The same pattern is morphing on this particular bus, and so amazing is this. Now when you're working with something that is closed like cylinder, you have to think of the pattern in a way that, okay, it is going to start here, end here. It might not really look good. Or for example, here you see something like this. It is not looking good. So you got to change the pattern in a way that it's more symmetrical 2D, so that it transforms symmetrically on that particular surface. For instance, let's see what happens when we use this pattern. Again, connect the same pattern to flatten tree, and then automatically everything will be morphed on that particular surface. And doesn't this looks nice? Doesn't this looks much better? Again, the square has been transformed into its own shape because of the way I have made the shape, but you can take time and a little bit sculpt it to get better outcome. Okay. Now, the other thing that I wanted to show you is the isocurve part. So for example, let me remove this. Let me on the control points again. You see, okay, let me pull the control point like this. So now here you see the isocurve is in this reverse S shaped, and now connect this to the surface and then you will see what I was talking about. Okay. So now you see the shape follows the isocurve. So you will see this was the isocurve. Now the pattern is bending here. So whenever you move the control point as well, the isocurve will change depending on how you want it. Not just the surface, but also the isocurve. That will also change the way the geometry is. Now let's take another example again in Rhino. So what I can say, I can just say arc. I can create just a semicircular arc. I can rotate it 90 degrees using gumball, then move it, and now I can rebuild curve as well. So similarly, how you rebuild a surface, you can also rebuild a curve. So let's say rebuild, and here I will say around 8 points and degree of 3 is okay. So I get some points on this particular arc as well. So I select those points, I will move them a little outside, then I will select these points, move it a little bit up, and then I will select these points and move it a little bit like that. Just changing the shape of this particular arc and showing that control point is not only applicable for surface but also for curve as well. And then I can extrude it. So I can say extrude curve again, and then whatever distance you want, can add it here. Now let's go back to rendered view. Now I will take this surface. I say set one surface, and now whatever that pattern was will fall on this particular surface. And how nice is this? Or you can change whatever pattern. So I can just connect this pattern here. Any pattern you have created, you just need to use this particular group of scripts, and then you see that kind of pattern gets applied on this particular geometry. And it's so simple. Once this is done, only change the surface, which is your target surface, and then in the flattened tree, add your pattern. And that's it. You can create various catalogs out of it. You can create a series of things that by just changing and tweaking, you get thousands and thousands of patterns. Okay, so I'm going to go back to my presentation. So once you have done, you have created, you end up with these catalogs of images that has been created. So we looked at how to create this. We looked at how to create this. This is simply baking this, removing some parts and mirroring that. We looked at how to create this. This one is the same process. I just added the triangular pattern. This one I showed you right now. You just create an arc and then you put this same pattern on it. This is hexagonal pattern on a vase. Okay. So that's what this particular video was mostly about. In the next video, which is going to be super interesting, we will see how to convert this into renders using Comfy UI. So the first one, let's say any brick pattern. Then the second one using this kind of nice corporate building. The third one, adding more depth. Again, we'll be using depth and canny, which we already looked at. And here below, I was like, okay, let's not go stick to architecture, make something else. The first one is architecture. The second one to me looked like a carpet. So I rendered it like a carpet. And this one was really interesting to me because I rendered it yesterday. And I was like, okay, this looks more like a roll from Subway or something. And you see the render. The cucumber is cut in that direction. The carrot, the lettuce, you see, this is the old, this is the new. So again, I always like to think of these patterns not restricted to the field of architecture or design. Once you create pattern, it's up to your imagination to how you will render it further. Okay. And the last one I simply created into a vase, and I did not add those punchers. I just created the pattern, but in the prompt I said cutouts on this particular lamp. So we'll look at all of these in the next video, but for today's video, that's mostly it. So I hope you like this video. I know I covered a lot of new concepts in this, And if there is any doubt on any concept, please do comment and I will be happy to help. Okay, so thank you for your time. Please do all the things that YouTube says again, which is like, comment, share, subscribe, and I will see you in the next one. Thank you.